Every time we see the bright colors of a butterfly, we marvel at its beauty. Rarely do we find such magnificence in the many objects around us. We can have the same experience of beauty when gazing upon the lotus leaf, which never gets dirty, and be amazed by a shark skin, which reduces drag, making it an even more efficient swimmer. These qualities inspired a whole community of scientists to develop new products with multifunctional properties, particularly for the automotive and toy industries, where colors and cleanliness remain essential factors.
The functional surfaces are addressing the needs from the European automotive industry, represented in this project by the companies Fiat, Meyer and CRP Centro Ricerche Plastica in Italy, and also the needs from the toy industry represented by the toy company Lego.
We are developing a mirror cap for exterior application, but the important thing is that we are developing a new surface that can be easily painted for different purposes, so for aesthetical purpose or for instance, different functional application like anti-fog.
Such properties are achieved by texturation or structure instead of modifying the chemical composition of the surface, which means without the use of pigments or any surface treatment. The benefit of such applications increases due to the recyclability potential.
The immediate impact is that many consortium members will exploit the project results and most likely create new products or services or improve their existing ones. At a more global level, projects like PLAST4FUTURE can contribute to a dramatic increase of the recycling prospects for plastic parts, which would in turn create new jobs and growth opportunities in the plastic sector, while at the same time protecting the environment and reducing the use of natural resources and the quantity of waste.
But how to replicate such effects of nature in the automotive and toy industry? This research inspired scientists to study surfaces more closely. The explanation behind these amazing properties is so minuscule we cannot even begin to imagine it. Nature brings us forward many years in the use of nanosurfaces and acquiring the best properties. We now have the equipment able to observe them. If we zoom in on a nano-structured surface, we find billions of dots placed in a determinate pattern. A supercomputer is needed to process the gigantic amount of information in order to design a pattern that reproduces the desired properties on a larger scale. In this 16 by 16 millimeter demonstrator pattern, there are 80,000 times 80,000 nano-sized engraved dots to achieve the colorization effect. If these were crops placed 10 centimeters apart, it would take 9 football fields to grow them. If the diameter of one of the dots would correspond to the size of a regular ballpoint pen, then the entire length of the pattern would correspond to a distance of about half a marathon. These fascinating nanostructures are observed and replicated under very strict conditions in the clean room of the Technical University of Denmark. Here, nanostructures can fabricate micro and nano systems at both prototype and small-scale production level. To be able to understand fully how to transfer this knowledge to the mass production of automotive parts and toys, we need to go back a few steps. The decoration surface for cars and toys is constructed with plastic, using the typical mass production system for these plastic components, which is injection molding. This manufacturing process consists of plastic injected into a steel mold. After demolding, the piece is ready for assembling in the product.
In PLAST4FUTURE, the objective is to add the capability of making nanostructures on injection molded plastic components.
PLAST4FUTURE has developed a technology to produce plastic components with the desired nanosurfaces by injection molding. The core technology lies in the creation of the mold, which can print the nanostructure to the plastic surface. But not all the molds are suitable for this purpose. Let's start at the beginning. Because regular steel has too many imperfections, it is just not up to the job. At the Udellholm foundry in Sweden, a highly specific steel composition is forged.
We have developed new tool steel, which is suitable for the technology with small grain size so that we can make controlled nanoscale textures in the surface of this material.
The steel is then shipped to Denmark, where it gets milled into the desired shape with extreme precision by the company Tool Partners. From here it goes back to DTU and into the clean room. There the nano pattern can now be transferred to the mold by NanoImprint lithography.
We have developed a technology for making nanolithography on the injection molding tools. And this both includes a NanoImprint technology where we can create the first pattern in a thin film of polymer which is coated inside the tool cavity. We have also developed methods for transferring that pattern into the steel either by etching or electroplating on these complex surfaces.
Well, the main challenge of the project is to apply the nanotextures in some areas of the mold when the geometry of the part is complex. On the other hand, we have optimized the injection molding process to obtain nanotexture surfaces directly from the mold.
Once the mold is inserted in the injection molding machine, the process is completed and we are finally ready for the production of the nano-engraved plastic parts.
We think that this technology has a very promising future in several applications. For us, the advantages are clear. The simplification of the process for the components give us a potential reduction of costs and environmental impact due to the reduction of the stages in the production of the aesthetic parts.
The structural color decoration that we generate with the PLAST4FUTURE technology enables manufacturers of plastic products to generate the color decoration directly in the injection molding process and thereby replacing post-processing.
As we have seen, we are surrounded by nano surfaces, even if we don't know it. This project opens the door to many applications in different industries, with various pattern designs producing distinct properties.
The PLAST4FUTURE technology is an example of how I believe that nanotechnology is going to enter our lives. It's not going to be an abrupt change, but rather that we will experience that products will be improved either in the performance or the recyclability, for example.
The circular economy challenges have been taken on board by this project. Using almost no additives in the plastics material in order to enhance its recyclability is the way forward for the European industry. So in overall terms, the competitiveness of the European plastics industry, this is a game changer.